Good morning, everybody. I am Avtada Madam. Already we have discussed two theorems which are related to pair of straight lines. Today we are going to discuss the theorem third, homogeneous equation of degree 2 in x and y. Ax square plus 2 hxy plus by square equal to 0 represents a pair of line passing through the origin if h square minus ab greater than or equal to 0. Proof for this theorem. Also observe the diagram here. Consider the homogeneous equation of degree 2 in x and y. Ax square plus 2 hxy plus by square equal to 0. Let it be equation first. To prove this theorem we need the two cases. First one is b equal to 0 and second one is b is not equal to 0. Consider the case first, that is if b equal to 0. Now put b equal to 0 in equation first. It becomes ax square plus 2 hxy equal to 0. Therefore, taking x as a common, we get x into the bracket ax plus 2hy equal to 0, which is the combined equation of lines. We can write this equation as x equal to 0 and ax plus 2hy equal to 0. We observe that these lines passes through the origin. Next, case second, if b is not equal to 0, then we multiply the equation first by b. Now it becomes abx square plus 2hbxy plus b square y square equal to 0. Transfer the term abx square on RHS. Now RHS becomes minus abx square. To make LHS complete square, we have to add h square x work to both sides. B square y square plus 2hbxy plus h square x square equal to h square x square minus ab x square. Now write both LHS and RHS in a square form. Now LHS becomes by plus hx bracket raised to square equal to RHS is into the bracket square root of h square minus ab bracket raised to square. Complete the bracket x square as h square minus ab greater than or equal to 0. Now take RHS term on LHS. Now it becomes equation like this, into the bracket by plus hx bracket raised to square minus into the bracket square root of h square minus ab bracket raised to square x square equal to 0. This is of the form a square minus b square equal to 0. We can write the equation as a plus b and a minus b. Thus now the equation becomes like this. This represents combined equation. Now we can write the separate equations like this, that is h plus square root of h square minus ab, complete the bracket x plus by equal to 0, and into the bracket h minus square root of h square minus ab, complete the bracket x plus by equal to 0. Thus, we observe that these lines passes through the origin. Therefore, equation abx square plus 2hbxy plus by square equal to 0 represents a pair of lines passing through the origin if h square minus ab greater than or equal to 0. Next, study remarks of this theorem. Remarks of this theorem is very important because the examples are based on these remarks. First remark is if h square minus ab greater than 0, then lines are distinct. Second remark, if h square minus ab equal to 0, then the lines are coincident. Third remark, if h square minus ab less than 0, then it does not represent a pair of lines. Fourth remark, if b equal to 0, then one of the lines is the y-axis whose slope is not defined and the slope of the other line is minus a upon 2h, where h is not equal to 0. Next, fifth remark is very important. This here, the sum of the slope m1 plus m2 equal to minus 2h upon b and product m1 m2 equal to a upon b. Next, bm square plus 2hm plus a equal to 0. Let it be equation 2. This equation 2 is called auxiliary equation. of equation first. Roots of equation 2 are slope of lines represented by the equation first. Thank you very much. This theorem is very important. It will come for board exam for 4 marks. So read it very well. Thank you very much.